Bismillahirrahmanirrahim. Assalam O Alikum, dear student. Today we will solve the numerical problem of unit number 11. Now, for our new syllabus, 6 SSC-II, unit number 11, sound, exercise 11, numerical problem 11.1 to 11.8. In this chapter, total numericals are 8 numericals. First of all, we can solve the first numerical. In first numerical, given statement is our normal conservation involve the sound intensity of about 3 multiplied by 10 raised to power minus 6 watt per meter square. Now we can find the two things. What is the decibel level of sound intensity and what is the intensity of sound for 100 decibel. First of all, we can understand the given data. Intensity of sound is given. We can find the intensity level in decibel. And in second part, intensity of sound in decibel is given. We can find the intensity of sound level I. Now we can write the given data for first part. Intensity of sound I is equal to 3 multiplied by 10 raised to power minus 6 watt per meter square. And we know that the intensity of audible sound I naught is equal to 10 raised to power minus 12 watt per meter square. In B part, sound intensity level SL is equal to L minus L naught is equal to 100 decibel. Now we can require that here two parts. In first part, intensity level L minus L naught, and in B part we can require that the intensity of sound I. Now using the formula, sound intensity level is equal to L minus L naught is equal to 10 log of I over I naught. For solution of first part, we know that sound intensity level is equal to L minus L naught is equal to 10 into log of I over I naught into decibel. First of all, putting the values, then we have sound intensity level is equal to L minus L naught 10 log of 3 multiplied by 10 raised to power minus 6 divided by I naught 10 raised to power minus 12. Here minus 12 move upward, power is positive. So 3 multiplied by 10 raised to power minus 6 plus. So answer is 3 multiplied by 10 raised to power 6. Now we have sound intensity level L minus L naught 10 log of 3 multiplied by 10 raised to power 6. So we have applying the logarithm rule. Here multiplication is addition and power is first to the digit. Now we have 10 log 3 plus 6 log 10. Now we can find that log 3 is equal to 0.4771. Then sound intensity level is equal to 10 into 0.4771 plus 6 into log 10 is equal to 1. 6 ones are 6. Now we can add 6 plus 0.4771 is equal to 10 multiplied by 6.47 into decibel. Then 6.47 multiplied by 10 is equal to 64.77 into decibel. Then is final answer of A part 64.8 decibel. Now for B part, sound intensity level L minus L naught is equal to 10 log of I over I naught. Putting the value, of sound intensity level 100 is equal to 10 log of I over I naught value 10 raised to power minus 12. Here we can also apply the logarithm rule. Then we have 10 is divided on other side, 100 divided by 10 is equal to 10, equal to log I. Here division rule is minus and minus 12 is also minus. Minus minus plus 12 log 10. Taking the log of 10 is equal to 1. So answer is 10 log I plus 12. 12 is moved on other side. This implies that 10 minus 12 is equal to log I. Taking the antilog on both sides, then I is equal to antilog of minus 2. The answer of antilog of minus 2 is equal to 0.01. This implies that I is equal to 0.01 watt per meter square. So the result of first part, sound intensity level L minus L naught is equal to 64.8 decibel. And in B part, intensity of sound I is equal to 0.01 watt per meter square. Now, in question number 2, if at anarkali bazar, Lahore, the sound intensity level is 80 decibel, what is the intensity level of sound there? First of all, write the given data. In given data, sound intensity level SL is equal to L minus L naught is equal to 80 decibel. Now we can know that intensity of audible sound is equal to I naught is equal to 10 raised to power minus 12 watt per meter square. Now we can require that intensity of sound I. We can using the formula to find the intensity of sound. Then we have sound intensity level is equal to L minus L naught is equal to 10 log of I over I naught into decibel. Now putting the values to find the solution. So we have sound intensity level is equal to L minus L naught 10 log of I over I naught. Putting the values L minus L naught is equal to 80. 80 is equal to 10 log of I over 10 raised to power minus 12. Now 10 is divided on other side. This implies that 8 is equal to log I plus 12 log of 10. We can apply here logarithm rule by our division method. So this implies that 8 is equal to log of I plus 12 log 10. 10 log of 10 is equal to 1. So we have log I 8 is equal to log I plus 12. 12 is moved on other side. This implies that log I is equal to 8 minus 12. 8 minus 12 is equal to minus 4. This implies that log I is equal to minus 4. Taking antilog on both sides, so I is equal to antilog of minus 4. Antilog of minus 4 is equal to 10 raised to power minus 4 watt per meter square. So I is equal to 10 raised to power minus 4 watt per meter square. Then the final result, intensity of sound I is equal to 10 raised to power minus 4 watt per meter square. Now, in question number 3, at a particular temperature, the speed of sound in air is 330 meters per second. If the wavelength of or note is 5 centimeters, calculate the frequency of sound wave. is the frequency lies in the audible range of a human ear. Now, first of all, we can write the given data. Speed of sound V is equal to 330 meter per second, and wavelength is equal to lambda is equal to 5 centimeter. Now, centimeter can be changed into meter. We can divide it by 5 by 100. So, 5 divided by 100 is equal to 0.05 meter. Then wavelength is equal to lambda. Lambda is equal to 0.05 meter. Now required that the frequency f is equal to question mark. We using the formula v is equal to f lambda. Then for a solution we can putting the value. Then we know that v is equal to f lambda. Then f is equal to v upon lambda. So frequency is equal to speed divided by wavelength. F is equal to V divided by lambda. Now F is equal to 330 divided by 0.05. So frequency is equal to 6600 Hz. Now we can change into scientific notation. The answer is 6.6 multiplied by 10 raised to power 3 Hz. We can write that the frequency f is equal to 6.6 multiplied by 10 raised to power 3 Hz or 6.6 kilohertz. And also, yes, the frequency lie in audible range of human ear because the human range of the frequency is 20 Hz to 20 kilohertz. So 6.6 in between them. So this frequency is a audible range. Now we can solve the numerical number 4. In 4 numerical, a doctor counts 72 heartbeats in 1 minute. Calculate the frequency and time period for the heartbeats. First of all, we write the given data. Number of heartbeats is equal to n is equal to 72 and time t is equal to 1 minute is equal to 60 seconds. Now we can calculate that frequency f is equal to question mark and in b part we can find the time period capital T is equal to question mark. So, using the formula, first of all, A part f is equal to number of beats divided by time. So, f is equal to n divided by t. And for time period, t is a reciprocal of frequency. So, time period is equal to 1 upon f. Finding the solution, we know that f is equal to number of heartbeat divided by time taken. Then f is equal to 72 divided by 60. 72 divided by 60 is equal to 1.2. This implies that frequency is equal to 1.2 Hz. Similarly, we can find the time period. T is equal to reciprocal of frequency. So 1 divided by 1.2. 1 divided by 1.2 is equal to 0.833 seconds. So the time period T is equal to 0.833 seconds. Final result, frequency f is equal to 1.2 Hz and time period t is equal to 0.833 seconds. In question number 5, a marine survey ship sent a sound of wave straight to the sea. It receives an echo of 1.5 seconds later. The speed of sound in seawater is 1500 meter per second. Find the depth of the sea at this position. First of all, write the given data. Here we can solve this question by two methods. Here we can solve first method and again in other slide we can find with other method. So first method you can write the given data, time taken t is equal to 1.5 second and speed v is equal to 1500 meter per second. Then required that depth of seabed is equal to h is equal to question mark. We can use the formula s is equal to vt. So we can find the distance. For solution, we know that s is equal to vt. Then s is equal to 1500 multiplied by 1.5. So 1500 multiplied by 1.5 is equal to 2250 meter. We know that the echo of sound distance must be half. So h is equal to s by 2. Then h is equal to 2250 divided by 2. Now 2250 divided by 2 is equal to 1125 meter. Then result of depth of water is equal to h is equal to 1125 meter. Now we can solve by other method. In other method we can use first of all write the given data. Total time is equal to time period. Then time period t is equal to 1.5 seconds and the echo time must be half, so t is equal to time period divided by 2. 1.5 divided by 2 is equal to 0.75. Now speed v is equal to 1500 meter per second. We can require that depth of seabed is equal to h. Then we use the formula S is equal to Vt. For solution, we know that S is equal to Vt is equal to 1500 multiplied by 0.75 is equal to 1125 meter. So the final result of the sea depth is equal to 1125 meter. Similarly, in question number 6, we can also solve by two methods. In first method, first of all, we write the given data. A student clapped his hand near a clap and heard the echo after of 5 seconds. What is the distance of clip from the student and speed of sound is taken by 346 meter per second. First of all, write the given data. Time taken t is equal to 5 seconds and speed v is equal to 346 meter per second. We can require that distance h is equal to question mark. Then we using the formula s is equal to vt. Then solution we can find that we know that s is equal to vt is equal to 346 multiplied by 5. 346 multiplied by 5 is equal to 1730 meter. Now the echo distance must be half, so s is equal to s upon 2 is equal to 730 divided by 2 is equal to 865 meter. So the result depth of seawater H is equal to 865 meter. Similarly, we can use the other method. In other method, first of all, write the given data. Total time is equal to time period. Then time period T is equal to 5 seconds and the echo must be half of the time. So echo have half time, then T is equal to 5 divided by 2 is equal to 2.5 seconds. Now the speed V is equal to 346 meter per second. We can require that distance mean h is equal to question mark. Then we have using the formula S is equal to Vt. Solution, we can know that S is equal to Vt is equal to 346 multiplied by 2.5. 346 multiplied by 2.5 is equal to 865 meter. So the result, the depth is h is equal to 865 meter. Now, in question number 7, we can also solve by two methods. First of all, we can see the first method. A ship sends out ultrasound that returns from the seabed is dedicated after 3.42 seconds. If the speed of ultrasound through a seawater is 1531 meters per second, what is the distance of seabed from the ship? First of all, write the given data. Time taken T is equal to 3.42 seconds and speed V is equal to 1531 meter per second. Now we can require that depth of seawater is equal to H is equal to question mark. We using the formula S is equal to Vt. Then we can find the solution. We know that S is equal to Vt is equal to 1531 multiplied by 3.42. Here we can use the 1531 multiplied by 3.42. Then answer is 5236.02 mean 5236.02 meters. We know that the echo distance must be half. So h is equal to s upon 2 is equal to 5236.02 divided by 2 is equal to 2618.01 meter. Now, the result of this question, the depth of seabed H is equal to 2618 meter. In other method, we can solve this numerical. So first of all, write the given data. In given data, time period T is equal to 3.42 and the echo have must be half time. So T is equal to 3.42 divided by 2 is equal to 1.71 second and speed V is equal to 1531 meter per second. Required the depth of water H is equal to question mark. We using the formula S is equal to Vt. Then solution we know that S is equal to Vt 1531 multiplied by 1.71. Here 1531 multiplied by 1.71 is equal to 2618.01 meter. So the result of depth of seabed H is equal to 2618 meters. In question number 8, the highest frequency of sound of human can hear is about of 20,000 hertz. What is the wavelength of sound in air at this frequency at the temperature of 20 Celsius? What is the wavelength of the lowest sound we can hear? About 20 Hz. Assume that the speed of sound in air at 20 Celsius degree is 343 meters per second. First of all, write the given data. Highest frequency F1 is equal to 20,000 Hz and lowest frequency F2 is equal to 20 Hz. Then speed of sound is equal to 343 meters per second. Now required that wavelength at F1 lambda 1 and wavelength at F2 is equal to lambda 2. Now we can use the formula V is equal to F lambda. Then we can find the solution. We know that for first part V is equal to F lambda. Then lambda 1 is equal to V upon F1. Then lambda 1 is equal to V upon F1, putting the values 343 divided by 20,000 is equal to 1.7 multiplied by 10 raised to power minus 2 meter. So the wavelength of lambda 1 at highest frequency 1.7 multiplied by 10 raised to power minus 2 meter. Similarly, we can find the lambda 2 is equal to V upon F2. Then we have 3043 divided by 20. So the wavelength of at of lowest frequency is equal to 1.7 multiplied by 10 raised to power minus 4 meter. Then result is that lambda 1 is equal to 1.7 multiplied by 10 raised to power minus 2 and lambda 2 is equal to 1.7 multiplied by 10 raised to power minus 4 meter. Now, in last numerical, a sound wave have a frequency of 2 kilohertz and wavelength is 35 centimeter. How long will it take to travel at 1.5 kilometer? First of all, write the given data. In given data, frequency f is equal to 2 kilohertz is equal to 2 multiplied by 10 raised to power 3 hertz. And also the wavelength lambda is equal to 35 centimeter. First of all, centimeter change into meter is equal to 35 divided by 100. 35 divided by 100 is equal to 0.35 meter. Now the distance S is equal to 1500 meter because given value is 1.5 kilometer, so change into meter multiply by 1000, so 1500 meter. Then required that time taken t. Now formula that we use S is equal to Vt. For solution, first of all, we can find that we know that V is equal to F lambda. Then F is equal to 2 multiplied by 10 raised to power 3 multiplied by 0.35. Then the speed V is equal to 700 meter per second. We also know that S is equal to Vt. We have S is equal to 1500 is equal to V 700 multiplied by T. 700 divided by other side, So T is equal to 1500 divided by 700. Then T is equal to 2.1 second. So the result is that time taken T is equal to 2.1 second. Best of luck, take care with next chapter and next chapter numerical. Meet with next video. Best of luck.